What exactly is dark matter and where does it originate? It is still a question that scientists cannot give a clear answer to. But recently, someone proposed a new idea which assumed that this mysterious substance may have come from a parallel process that coincided with the Big Bang, or the massive expansion that gave birth to the universe 13.8 billion years ago. Professor Catherine Fries and Dr. Martin Wolfgang Winkler, astrophysicists from the University of Texas, USA, Austin campus, published a paper on the origins of dark matter and some gravitational waves on the Academic Document Archive website, archive.org, on February 22nd. The author of the said article stated that the Big Bang event may be like a coin with two sides. This is when radiation and the massive expansion of ordinary particles as we know them occur. Another process known as the Big Dark Bang also caused a massive expansion of dark matter in the universe. Previously, astrophysicists assumed that dark matter arises within processes that follow the end of the Big Bang, by quantum field that drove the expansion of the universe in less than 20 minutes will dissipate and become protons and neutrons, which is the structure of the atomic nucleus, or the basis of all things. However, there are still some quantum fields that did not decay after the Big Bang. This special quantum field later gave rise to dark matter, as the universe expanded and began to cool, but the above assumptions about dark matter are vague. It is not consistent with the description of the process of the formation of nuclei in the Big Bang event that physicists use. Dark matter emerged from a parallel Big Bang event, or Big Dark Bang, which is a separate process of dark matter formation. The article by Professor Fries and Dr. Winkler states that if a massive expansion of dark matter or a dark Big Bang event really existed, this expansion must have occurred within a month or so of the Big Bang of ordinary matter. We can find traces of this dark Big Bang event from gravitational waves that was released in such an event, and likely still remains in the present universe. This information comes from ripples that travel throughout space. It can indicate what happened in the dark Big Bang event. And recently, the International Dark Energy Survey, DES, project has once again proven Einstein's general theory of relativity, and found that this century-old concept is still accurate, in the sense that the gravitational value, it has always been constant and unchanged. Since the beginning of the universe some 13.8 billion years ago, the DES project originally wanted to examine the dynamics of dark energy throughout the history of the universe, to try to explain the phenomenon that why did the universe expand at a constant rate for the 8 billion years after the Big Bang, but it began expanding at an accelerated rate 5,000 million years ago. This phenomenon may be due to the influence of dark energy. Or is it because of the gravity of the universe that keeps space objects together into groups that have changed in value? If the latter case is true, it means that Einstein's general theory of relativity made an incorrect prediction. To prove the cause of the universe expanding at an accelerating rate, a team of DES astrophysicists used a telescope in Chile to study images of galaxies 5 billion light-years from Earth by looking through what is called weak gravitational lensing, a rendering of the Nancy Grace Roman Space Telescope that will be used to observe dark energy in the future. The gravitational lensing phenomenon will occur when light traveling from the distant depths of space is distorted and bent while passing by a massive object with enormous gravity, such as black holes or galaxy clusters, causing the image of distant, old galaxies to be enlarged. It also looks more twisted and curved into a ring. It's like using the lens of a magnifying glass to look at it. Distortion of space-time. This appears in images of ancient galaxies viewed through gravitational lenses. Can be calculated to know the value of gravity at each time in the universe. The results of the investigation found that this value was relatively constant and almost unchanged throughout the 5,000 million years that the universe expanded at an accelerating rate. The James Webb Space Telescope uses gravitational lensing, captured images of galaxies tens of billions of light years away. The results of the study were published in the journal Physical Review D of the American Physical Society. The team says this investigation continues to validate Einstein's theory of general relativity. But at the same time, the influence dark energy may have on the accelerating expansion of the universe. It will remain a mystery that must continue to be answered. Next year, the European Space Agency, the Euclid Space Telescope, will be launched to investigate dark matter and dark energy in deep space, including measuring the accelerating expansion of the universe more accurately. NASA plans to launch the Nancy Grace Roma Space Telescope on a similar mission in 2027. If you like space stories, you are our friend. Click follow and press the bell so you don't miss any action.